In this project, I will demonstrate how to use infrared proximity sensor for distance measurement. First, connect Blue base shield for Arduino interface on your FPB RA0E1 board. Then connect infrared proximity sensor to A3 JST connector. The signal line will be connected to A4 of Arduino interface. Open Escape Studio and click on this file icon, then select New, then select Run as C++, then select Run as RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on this Next button. From this drop-down menu, select FPB RA0E1 board. After board selection, click on Next button. Here select Executable and No RTOS option. Then click on Next button. Here select Bare Metal Minimal and click on Finish. IDE will take some time to load your project. By default, IDE will open FSP configuration file. Click on Stack tab, then click on New Stack, then click on Analog. We need to add analog stack as infrared proximity sensor output value is analog signal. We need to modify this stack according to our requirement. Click on ADC stack, then open properties window. Then expand general tab. For conversion options, select sequential and then select no wait option. Now expand Input tab and select Channel 2. Now expand Interrupt tab and select Software for trigger source. Now we need to configure A4 pin for analog input. Click on this analog channel 2, then click on this arrow button. It will open analog pin settings. Here select P08 for analog channel 2. By default P08 is already configured in FSP configuration file. Scroll up to find P08 and disable any other GPIO function. According to Quick Start Guide document, analog channel 2 is connected to P08 which is connected to A4 of Arduino interface. We are not using any other analog pin for this project. Disable any other analog pins and click on Generate Project Content. IDE will take some time to configure your project. After that, expand src folder and open hallentry.c file. After that, you can add Sagar RTT source code in your project. Now I am adding commonutils.h file in src folder. commonutil.h file contains configuration data related to Sagar RTT terminal. Now open hallentry.c file and include commonutil.h file. After that, you need to declare these variables here. In Project Explorer, expand Developer Assistant tab and drag and drop ADC open function call in hallentry.c file. Declare FSP error variable and use assert function to make sure analog open function call was successful. Now from Developer Assistant tab, drag and drop ADC scan config function call in hallentry.c file and use assert function to make sure scan config function call was successful. Now from Developer Assistant tab, drag and drop ADC scan start function call in hallentry.c file and use assert function to make sure scan start function call was successful. After that, declare while1 loop here. In while1 loop, from Developer Assistant tab, drag and drop ADC read function call. Use assert function to make sure read function call was successful. In ADC read function call, for second argument we need to define channel. Use ADC channel 2. For third argument, we need to define source variable where we want to store ADC read value. For distance measurement, we need ADC value in actual voltage. Define these macros here. By using this formula, we can convert ADC value into actual voltage value. Now use SNPrintf to get string representation of float values. Sagar RTT don't support float value, so we need to convert into string representation of float value. After that, use appprint function to log data on Sagar RTT terminal. Now click on your project name, then click on this hammer icon to build your project. After build is complete, right click on your project name, then select debug as, then select run as GDB hardware debugging. After some configuration, IDE will ask you to switch to debug perspective. Click on switch button to switch to debug perspective. In debug mode, click on this resume button twice, then open Sagar RTT terminal. There is some mistake in project configuration we need to debug as it is showing 0 for both ADC and float value. First, add some delay in the program using RBSP software delay. After that, according to above warning, we need to send the address of ADC read variable. Now we need to build and debug our project again. For that, click on your project name, then click on hammer icon to build your project. After that, right click on your project name, then select debug as, then select NSS GDB hardware debugging. Now when you use Sagar RTT terminal, you can observe that we are reading ADC value correctly. According to datasheet, when obstacle is near to infrared sensor, ADC value will rise. As you can observe here, when I place an obstacle near infrared sensor, ADC value is increased, but still there is an error related to float values. Right click on your project name, then open properties. Now click on C build, then click on settings. Under GNU ARM cross C linker, click on miscellaneous, then enable use float with nano printf. Now click on apply and close. Now click on your project name, then click on this hammer icon to build your project. If your project is already running in background, clicking the hammer icon will restart the debugging session. Now click on this resume button. After pressing the resume button, you can observe that the application is suspended. After debugging, I have found out that when using float with nano printer, we need to enable heap use in BSP tab using FSP configuration file. Open FSP configuration file, then click on BSP tab, then open properties. Scroll down to find RA command tab. Now you can define heat memory here. I am using 0x400 bytes. Now we don't need to change anything further here. Click on generate project content. After that, click on your project name, then click on this hammer icon to build your project. After a successful build, right click on your project name, then select debug as, then select NSS JDB hardware debugging. Click on switch button to switch to debug perspective. In debug mode, click on this resume button twice, then open Sagar RTT terminal. Now you can observe that we are receiving both values correctly. If I move any obstacle in front of infrared proximity sensor, you can observe the analog value changing accordingly. Maximum analog value is 2.2, which is equal to 10 cm, and minimum analog value is 0.4, which is equal to 80 cm. I have tested both these values. To find the distance between 10 cm and 80 cm, you can use the previously shown graph.